Good morning, all of you. Welcome to Unacademy. Today we will going to see our next chapter on discrete mathematics. This lecture we will cover up mathematical induction. We will see the examples which are depending upon the mathematical induction, and we will cover it in this lecture. Let's start. Before going to start this, let me introduce myself. Myself, Dhanashree Mam. I completed my MSc in mathematics from Mumbai University and also having 13 plus years of teaching experience. I mentored more than 10,000 plus students for the engineering. Now, let's start. How I will tell you how to install the Unacademy's learning app. First, go to your mobile's Play Store app, then search Unacademy's learning app. After that, install the Unacademy's learning app. Then step 3, here you have to manage your goal. कि हम लोग यहाँ पे अभी गेट एंड ईएससी के लिए पढ़ रहे हैं, so you can manage your goal here गेट एंड ईएससी and you can take any subscription from either plus subscription, free courses, special classes, anything you want to choose. And I will tell you each subscription plan has different benefits. So by using that you can choose your best plan and then press the get subscription button. Now the next important thing here is to tell you, you can choose your subscription plan either for 12 months or for 24 months. It is so which plan it is compatible to you, you can choose it here. So if you are going to prepare for the GATE 2022, so I will suggest you can choose the 24 months plan so that it will beneficial for you. And the most important thing is that if you want 10% discount on your subscription fees, you can use my promo code DSP so that you will get a 10% discount on your subscription. And the last thing is that you can choose any one of this plan method to pay your subscription. Now, let's start our actual topic. Now here, unlock the free plan of Unacademy. You can use any free plan, that is special classes, live test series, special fees, Unacademy Combat. You can use my promo code DSP to get the 10% discount on your subscription plan. Next, here you can use first thing here is that now see the statement of principle of mathematical induction. Okay, to prove any statement, we will use the more technique proof of statement is principle of mathematical induction. To prove the given statement, whether the statement is true or not, we will use the principle of mathematical induction. So it is stated, see, let P of n be a statement involving a natural number n. Let P of n be a statement involving a natural number n. First one, if P of n is true for n is equal to m, where m belongs to n, where m is natural number belongs to n, assuming that P of k is true for all k greater than or equal to m, then we prove that P of k plus 1 is also true. Then P of n is true for all natural number n greater than or equal to m. Okay. Now see here how we stated. तो हमें कौन सा भी स्टेटमेंट अगर यहाँ पे प्रूव करना है whether it is true or not, so for that we will go from the first natural number. If it is given directly the natural number, suppose sometimes in example it is given that prove for n greater than or equal to 2, it means in that case, in that example, your natural number starts from 2, right? And if it is not given, if starts from n greater than or equal to anything, so you have to assume by default this statement is for the set of natural number, right? So your first natural number is n, so you will start your principle from n is equal to 1. So assuming that P of n be a statement involving a natural number, so P of n is true for n is equal to m, where m is belongs to n. So assuming that P of k is true for k is greater than or equal to m, we prove that P of k plus 1 is also true. Then P of n is true for all natural number n greater than or equal to m. Okay? So we will see the examples depending on this principle of mathematical induction. So first example is given to you. So prove that by mathematical induction for n greater than or equal to 1, 1 into 2 plus 2 into 3 plus 3 into 4 and so on, n into n plus 1 is equal to n into n plus 1 into n plus 2 by 3. Okay. So for n is equal to, so we will assume that the result is true for. So there are three steps. First, we assume that the result is true for n is equal to first natural number. Then we assume that the result is true for n is equal to k, and we will prove that the result is to be hold or true for n is equal to k plus 1. Now let's start how to prove it. So first of all, we will see the LHS for n is equal to step 1. Step 1 here. For n is equal to 1, because here given the condition n is greater than or equal to 1, it means your principle of mathematical induction starts from n is equal to 1. So for n is equal to 1, we will use here LHS. So your LHS will be here, put n is equal to 1. So 1 into 1 plus 1, that is 2. Right, here n is equal to 2. Right, now, so n is equal to 2. So by see the LH is your LHS. Now consider RHS. So RHS is given by n into n plus 1 into n plus 2 by 3. Now put here n is equal to 1. So we will get 1 into 1 plus 1 into 1 plus 2 upon 3. That is 1 into 1 plus 1. It means here is 2. 2 into 3 is 6. 6 by 3, it means 2. Now if you observe here, LHS is equal to RHS for n is equal to 1. LHS is equal to RHS for n is equal to 1. It means that the result is true for, n is equal to 1. Right? The result is true for n is equal to 1. Okay? So you will get it. The result is true for n is equal to 1. Now next step. Next step of mathematical induction is we have to assume that the result is true for step 2. Here step 2, we assume that the result is true for, we assume that result is true for, we assume that the result is true for n is equal to k. Okay, the result is true for n is equal to k. Now, for as the result is true for n is equal to k, we will see that here 1 into 2 plus 2 into 3 plus and so on n into n plus 1. It means we can write here k into k plus 1 instead of n. Here we can write k. So n is equal to k into k plus 1 is equal to k into k plus 1 into k plus 2 upon 3. Here we already assume that the result is true for n is equal to k. Right? Now once you are getting the result is true for n is equal to k, the steps 3 we will prove that the result is true for, we prove the result is true for, result is true for n is equal to k plus 1. Right? So we will prove that the result is true for n is equal to k plus 1. So here, that is to prove that, what we want to prove, that first of all write down, that is to prove that here 1 into 2 plus 2 into 3 plus and so on, k plus 1 into k plus 1 plus 1, it means k plus 2 is equal to k plus 1 into k plus 1 plus 1, it means k plus 2, and here is k plus 3 upon 3. That is, we have to prove this is equal to this. So consider, for that we will consider the LHS. Okay. Step 3. Consider, take the LHS, consider 1 into 2 plus 2 into 3 plus and so on. You will get here k into, here k plus 1 into k plus 2, so on, plus k plus 1 into k plus 2. Okay. as we know that this is your next step, right? 1 into 2 plus 2 into 3 plus and so on. This is last step, k plus 1 into k plus 2. But before this step, there is one point, 1 into 2 plus 2 into 3 plus and so on, plus k into k plus 1 plus k plus 1 into k plus 2, right? K plus 1 into k plus 2. So before this term, there is one term, but we know that the result is true for up to this steps, right? The result is true for up to this step. So instead of this step, can I write this as k into k plus 1 into k plus 2 by 3, as the result is hold for n is equal to k. So here k into k plus 1 into k plus 2 by 3, we can write k into k plus 1 plus k plus 2 by 3 plus here k plus 1 into k plus 2. Okay, so I'm taking the denominator same. So you will get here, instead of this term, we can write this term. So k into k plus 1 into k plus 2 plus 3k plus 1 into k plus 2 upon 3. Right? So instead of this, can we write, can I take k plus 1 and k plus 2 common? So k plus 1 into k plus 2 into bracket will get k plus, here k plus 1 into k plus 2 common, plus 3k, right? Plus 3k already here. So k into bracket k plus 1 into k plus 2 into k plus 3 upon, so that is we want to prove, right? So ultimately here k plus 1 into k plus 2 into k plus 3 by 3, that is your RHS. Here k plus 1 into k plus 2 into k plus 3 by 3, that's we want to prove. So by induction hypothesis, the result is true for all the natural numbers. So this result is true for all the natural number n greater than or equal to 1. So by induction hypothesis, the result is true for all the natural number n greater than or equal to 1. Okay. Now we will further for the next step, that is induction. So that by induction, 1 square plus 3 square plus 5 square plus and so on, 2n minus 1 bracket square is equal to n into 2n minus 1 into 2n plus 1 by 3. Okay. So here we will solve by using mathematical induction. So for step 1, for n is equal to 1. So you will get for n is equal to 1 as 1 square plus 3 square plus and so on. So put n is equal to 1. We will get here 2 into 1 LHS, 2 into 1 minus 1 bracket square, that is 2, 1, so it is 1. Okay, RHS, and write RHS 1 into 2 minus 1 into 2 plus 1 upon 3. So 1 into 1 into plus 1, so 3 by 3. 3 by 3 is equal to 1. So for n is equal to 1, LHS is equal to 1, RHS is equal to 1. So by induction hypothesis, the result is true for, the result is true for equal to 1, right? The result is true for n is equal to 1. Now, we assume that the result is true for n is equal to k. Step 2, we assume the result is true for, result is true for equal to k. For that we will get 1 square, or 1 square plus 3 square plus 5 square plus and so on, plus 2k minus 1 bracket square equal to 1k into k plus 2k minus 1 to 2k plus 1 by, right? That is true for n is equal to k. Step 3. Prove that result is true for is equal to k plus 1. Okay? Result is true for n is equal to k plus 1. We assume that for that is to prove that here 1 square plus 3 square plus and so on plus 2 into bracket k plus 1 minus 1 bracket square is equal to k plus 1 into 2 into bracket k plus 1 minus 1. So here 2k plus 2 minus 1. So 2k plus 1, k plus 1. Here 2 into bracket k plus 1. So 2k plus 2 plus 1. So 2k plus 3. There is 2k plus 3 by 3. Right? So 1 square plus 3 square plus and so on. 2 into k plus 1 minus 1 bracket square is equal to k plus 1 into 2k plus 1 into 2k plus 3 by. Okay. So for that consider LHS. Consider that 1 square plus 2 3 square plus 5 square plus and so on plus 2k minus 1 bracket square plus 2k plus 1 bracket square is equal to k into 2k minus 1 into k plus 1 upon 3 plus 2k plus 1 bracket square, right, is equal to here 2k plus 1 by 3, k plus 1 by 3 to bracket 2k square minus k plus get 2k plus 1 bracket square, right? 3 into 2k first of all, make the denominator same, k into 2k minus 1 into k plus 1 plus 3 into 2k plus 1 bracket square upon 3 is equal to k into bracket 2k plus 1. So take 2k plus 1 common, right? Get here 2k plus 1 into bracket k into 2k minus 1 plus 3 into 2k plus 1. What? Right? Get here 2k plus 1. What will be 2k plus 1? Add one slide. K plus 1 by 3. K plus 1 by 3 to bracket. You will get here 2k square. Right? 2k square minus k plus 6k plus 3. Ultimately here 2k square plus 5k plus 3. Right? Then 2k plus 1 by 3 bracket 2k square plus 5k plus 3. So 2k plus 1 by 3 bracket 2k square plus k plus 2k plus 3. Right? So ultimately k plus 1 by 3 bracket, now k common, bracket k plus 1, right, and plus 3 to bracket k plus 1. Get here 2k plus 1 by 3 bracket k plus 1 into 2k plus 3. Right? Ultimately, that we want to prove that RHS k plus 1 into 2k plus 1 into 2k plus 3 by 3. K plus 1 equal to, therefore the result is true for, result is true for n is equal to k, and therefore the result is holds for all the natural number n. Therefore result hold, therefore p of n is true for all n greater than or equal to 1. Therefore result is for all n greater than or equal to 1. Next, show that 1 cube plus 2 cube plus 3 cube plus and so on plus n cube is equal to 1 plus 2 plus n and so on bracket square. Cube of each natural number, sum of the cubes of each natural number equal to 1 plus 2 plus 3 and so bracket is first. That for equal to 1 LHS equal to 1 cube cube equal to 1, the RHS plus 2 plus and so on plus 1 square equal to, the 1 square again square again 1. LHS is equal to RHS. Result is therefore result is true for equal to 1. Step 2. Step 2. Assume the result is true for assume the result is for n is equal to k. Assume the result is true for n is equal to k. Therefore, we get 1 cube plus 2 cube plus and so on plus k cube is equal to the 1 plus 2 plus 3 plus and so on plus k bracket square. Right? Then we have step 3. Prove the result is true for n is equal to k plus 1. For that, assume, that is to prove that 1 cube plus 2 cube plus and so on k plus 1 bracket cube is equal to 1 plus 2 plus 3 plus and so on plus k plus 1 bracket square. Right? So we will consider here, the LHS equal to 1 cube plus 2 cube plus 3 cube plus and so on plus k plus 1 bracket cube, but before that term is k cube, right? So as we know that the result is true for n is equal to k. For this, up to this step, 1 cube plus 2 cube plus 3 plus and so on up to k cube, the result hold for n is equal to k. For instead of this, we can write here 1 plus 2 plus 3 up to 3 and so on bracket square, that is k square, right? So we will get here we know that the sum, that is 1 plus 1 square, 1 plus 2 plus 3 plus and so on plus k bracket square plus k plus 1 bracket The most important thing in this example is that later, yeah, k plus 1 bracket square into bracket k square plus 4 by 4, right? Here k plus 1 bracket square. So we take k plus 1 bracket square into bracket. So here k plus 1 bracket square into bracket, get k plus 1 bracket k plus 2 bracket square, right? Plus 2 bracket square by 4. With nothing but, can I write this as k plus 1 into k plus 2 by 2 bracket square, right? With nothing but your 1 plus 2 plus 3 and so plus k in square. That's to prove. Now show that 1 square by 1 into 3 plus 2 square by 2 3 into and so on, plus n square upon 2n minus 1 2n plus 1 and so on n into n plus 1 upon 2 into 2n plus 1. Exactly similar we have to do this for n is equal to 1. Step 1, n is equal to 1. For n is equal to 1, for n is equal to 1, can prove LHS here 1 by square by 2 minus 1, that is 1 plus 1. LHS is 1 by 3. 1. Here LHS 1 by 3 by 3. Then take RHS. RHS is equal to, here you will get 1 in plus 1 by 2 into plus 1. That is 2 by 2 into cancel out, so 1 by. So LHS is equal to RHS. Result is true for n is equal to for -1 k plus 1 2 in bracket k plus 1 plus 1 is equal to k plus 1 into k plus 2 upon 2 bracket plus 1 plus 1, right? That's equal to 2. Next is here, consider, to prove this, consider your LHS at 1 square upon 1 into 3 plus 2 square upon 3 5 plus and so on, plus a plus 1 upon bracket square upon 2 into k plus 1 minus 1 plus 1, okay? Right here, nothing but write this as 1 square upon 3 plus 2 square upon 3 into 5 plus and so on, k square upon 2k minus 1 k minus sorry for the disturbances. This is technical 1 upon 1 square upon 1 into 3 plus 2 square upon 3 into 5 plus and so on square upon 2k minus 1 into k plus 1 plus, here we can see, plus, here we can see k plus 1 bracket square upon, then write 2 into bracket plus 1 bracket minus 1 to 2 into k plus 1 plus 1, right? You, instead of this, as we already proved, the result is for, yeah, the result is for n is equal to k plus 1 and n is equal to k. Instead of this, we can write k into k plus 1 upon 2 into 2k plus 1 plus k plus 1 bracket square upon 2k plus 1 into 2k plus 3, right? So instead of this, we can write this. Here, can I take k plus 1 common? K plus 1 upon 2k plus 1 is common. To bracket k into 2k plus 3 plus 2 into k plus 1 upon 2 into 2k plus 3, right, equal to k plus 1 upon 2k plus 1 bracket 2k square plus 3k plus 2k, it means 5k plus 2, right, upon 4, 2 into 2k plus 3. Factorize it, we get k plus 1 upon k plus 1, right, k plus 1 into k plus 1 to bracket 2k square plus 4k plus k plus 2 upon 2 into bracket 2k plus 3 equal to k plus 1 upon 2k plus 1 bracket 2k into bracket k plus 2 plus 1 into k plus 2 upon into 2k plus 3 equal to k plus 1 to k plus 2 upon to 2k plus 8 equal to k plus 1 to k plus 1 plus 1 upon 2 into bracket 2 into k plus 1 plus that's thus the result is true for all the natural. Thus the result is all the natural. Okay. The next, show that 1 into 1.4 n upon 2n plus 1. So n upon 2n plus 1. For that, again we assume that the result is for the induction basis. Induction basis we have for n is equal to 1. So LHS get 1 upon 2n minus 1. Okay? So 2 n minus 1, it means 1. There 3 by 3. Right? RHS get 1 upon 2 plus 1. So LHS is equal to RHS. Result is for n is equal to 1. Right? The result is for n is equal to 1. We assume that the result is true for 2. Step 2. Result true for n is equal to. So therefore, have here 1 into 1 upon 1 into 5 plus and so on upon 5 and so on upon 2k minus 1 equal to k upon 1. Result is true for n is step 3. Prove that for n is equal to k plus, right? That the result is true for n is equal to k plus. That is, have to that here 1 upon upon 1 plus 1 5 1 plus 1 upon 2k plus 1 to 2k plus 3 equal to. Now for this, we already proved that the result is 2 for n is equal to k. So we have here is 2 plus 1. See, k upon 2 k plus 1, right? Through this reduction and k upon 2k plus 1 plus 1 upon plus 1. K2 square plus 3k upon k plus 1 k plus here 2k plus 1 plus 1 upon 2k plus 1 on 2k plus 1 into 2k plus 3 divided by, now see here 2k plus 1 2k plus 1 get cancel out, k plus 1 upon 2k plus 3 equal to, we can write k plus 1 upon into k plus 1 plus 1. That's here, that is here k plus 1 upon k plus 1 upon 2 into k plus 1 plus 1. Hence the result is true for all natural number. The result is true for all natural. Okay? So that nq plus 2n is divisible by 3 for all n greater than or equal to 1. So that the result is true for nq plus 2n is divisible by 3 for all n greater than or equal to 1. Now, so this is different type of, you can see here, for the basis of induction, for n is equal to 1, we have, for n is equal to 1, get 1 plus 2, right, equal to 3, is divisible by 3, Therefore, result is for n is equal to 1. Now, assume the result, step 2, our step 1, right? Assume the result true for n is equal to k. That is, n is equal to k, it means what? Get k cube plus 2k is divisible by right? Plus 2k is divisible by 3. Now, step 3. Prove that the result is true for result is true for n is equal to k plus 1, right? Result is true for n is equal to k plus 1. Now, so for that, that is to prove that k plus 1 bracket cube plus 2 into k plus 1, right? K plus 1 bracket cube plus 2 into k plus 1 is nothing but here k cube plus 3k square plus 3k1, right? Plus 2k plus 2 means here k cube plus 3k square plus 3k plus k plus 3. So we can take here k cube plus 2k plus 3 into bracket k square plus k plus 1, right? As we have seen that by induction hypothesis k cube plus 2k is divisible by 3, right? So k cube, since k cube plus 2k is divisible by 3 and k square plus k plus 3, the multiple of 3, right? Multiple of 3, hence it is also divisible by 3 and sum of the numbers which are divisible by 3 is again a divisible by 3. Therefore k plus 1 bracket cube plus 2 into k plus 1 is divisible by so k plus 1 into k to k plus 1 is divisible by 3, right? So hence the result is true for all the natural number n greater than or equal to k plus 1. All the natural number, hence result is true for n is greater than or equal to 1. Okay? I hope this is clear to you how to find out the induction on the basis that the numbers are divisible by. Exactly similar way we will prove this result. The result n raised to 4 minus 4n square is divisible by 3 for n greater than or equal to 2. So on the induction basis, for n, now here see, n is greater than or equal to 2. So your induction starts with 2, right? On induction basis for n is equal to 2. So here 2 raised to 4 minus 4 into 2 square. So which is equal to 16 minus 2 square is 4 into 4, 16. 16 minus 16, 0. And 0 is divisible by 0 is divisible by 3. 0 is divisible by 3. Hence, by induction hypothesis, step 2, this is your step 1. Step 2, by induction hypothesis, is assume the result is true for, assume the result is true for, assume the result is true for n is equal to k. Okay. That is k raised to 4 minus 4k square is divisible by 3. Is divisible by 3. And to prove that, step 3, to prove that result is true for n is equal to k plus 1, right? So we can take here consider, that is to prove that k plus 1 bracket raised to 4 minus 4 into k plus 1 bracket square is divisible by 3, right? Divisible by 3. So for that consider here k plus 1 bracket raised to 4 minus 4 into k plus 1 bracket square. is equal to, now expansion, binomial expansion of this is k raised to 4 plus 4k square plus 6k square plus 4k plus 1 minus, yeah, 4 into bracket k square plus 2k plus 1, right? So ultimately this will gives you k raised to 4 plus 4k square plus 6k square, means this will gives you 4k square plus 6k square plus 4k plus 1 minus 4 here plus 1 minus 4k square minus 8k minus 4, right? Then minus 8k minus 4. So you will get ultimately this is k raised to 4 minus 4k square. Why I am taking this in bracket? Because we assume that k raised to 4 minus 4k square is divisible by 3. So I will get this, right? So these two terms are there. Now plus 4k square plus 6k square is 4k square plus 6k square minus 4k and minus 3. So you will get here 6k square 4k cubes. 4k cube. So 4k cube. So plus 4 into bracket k cube minus 2k minus 1. Right? K cube 4 into brackets and we are 4k square minus 4k raised to 4 minus 4k square 4k cube plus 6k square plus 4k plus 1 plus 4k square minus 8k plus 1 plus 8k plus 4k, right? Minus 8k plus 4k, so that is minus 4k. So k cube minus 8k. Okay. So you will get here k raised to 4 minus 4k square plus 4 into bracket k cube plus k. K cube into k square. 4 into bracket k cube plus 2k plus 2k minus plus 6k square plus 6k square plus 12k minus 4 minus 3. Here you will get multiple of 6, right? So k raised to 4 minus 4k square is divisible by 3. Well, by 3. And k cube plus 2k is divisible by 3 again. So the sum is also divisible by 3. Therefore, k plus 1 bracket raised to 4 minus 4 into k plus 1 bracket square is divisible by 3. Divisible by. I hope you are getting it clearly how to find out the method. I use this. It immediately. Last example we will solve by induction hypothesis. Step 1. Or n is equal to 1. Get minus 1 raised to LHS 1 minus 1 into 1 square raised to 0 1. So here is 1. RHS 1 raised to 1 minus 1 1 plus 1, 2 by 2 equal to 1. So LHS is equal to RHS. LHS is equal to RHS. Did this. Step 2. For n is equal to k. 1 square minus 2 square plus 3 square minus 4 square plus and so on. Minus 1 raised to k minus 1 into k square is equal to minus 1 raised to k minus 1 into k plus 1 by 2. Right? So assume that, do that, step 3. Right directly here. 1 square minus 2 square plus 3 square minus 4 square plus and so on, plus minus 1 raised to k minus 1 k square plus minus 1 raised to k plus 1 bracket square. So this have the reason, that is y minus 1 raised to k minus 1 k into k plus 1 by 2 plus minus 1 raised to k plus 1 by plus 1 bracket square is equal to minus 1 raised to k minus 1 raised to k to minus 1 into k plus 1 minus k by 2 plus k plus 1 common, minus 1 raised to plus 1 bracket minus k plus 2k plus 2 by 2, right, equal to minus 1 raised to k plus 1 bracket here and take plus 2, so plus k plus 2 by 2, right, plus 2 by 2. Hence, result is true for n is equal to k plus 1. Right? That's I hope you have clearly understood the mathematical induction. I took 8 examples of different types. Okay? Hope you are clear how to solve the examples on mathematical induction. So it will be clear to you. So totally we will find out this principle of mathematical induction. This is true. So if you are liking my videos, please do like, share and subscribe. I will be here the same time tomorrow in the morning 11:15, the new topic, that is relations and functions.